In this video, we're again going to look at unions and intersections from Chapter 1, Section D.2. Let's take a look at a Venn diagram that has one set, and we'll call that set A. Remember that the rectangle represents the universal set, and everything that is outside the circle, but inside the rectangle, is the complement of A. Also remember from a previous video that the union of two sets is really a way to say an element is either in one set or the other. This is another way to say or. Okay? So if I shade the region here, I'm using A and its complement. If I shade the region to highlight what elements we're talking about, right? There's set A, and here's the complement of A, and we quickly see that everything inside the rectangle is shaded, while we know that the rectangle represents the universal set U. So this is what we call an identity, which is true for any set. Any set A with a union of its complement is going to produce the universal set. Let's take a look at another Venn diagram. Again, I'm going to draw one set on the inside, and we'll label it set A. And we have the complement of A and the universal set. This time I'm going to take the intersection. And remember from a previous video that intersection is really another way to say and. So now we're looking at elements that are both in A and the complement of A. Well, normally we'd see another circle here where they overlap, and I could easily pick out the elements that are in both, but there's no point inside the rectangle where I'm simultaneously in A and A prime. Therefore, the intersection of A and its complement produces the empty set. There are no elements in it. Again, this is an identity. It's always true, always true for any set. Now let's consider another Venn diagram. This time I'm going to draw two circles to represent two sets. So we have set A and we have set B, and we have the universal set. I'm going to redraw this Venn diagram so we can compare two scenarios. Voila. Now in the first diagram, I want to consider the complement of A and then the complement of B. So first I'm going to shade the region that is the complement of A. And that's everything that's outside the circle A. I'm then going to shade the region that is the complement of B. And that is everything that's outside of the circle B. Notice the region where I have both red and green shading, which I'm going to replace with blue shading. It's everything that's outside the two circles. Okay? So, because I'm including both the red and the green shading, that's an and statement. This is an intersection. Now in the bottom diagram, I want us to consider the union of A and B. And I'm going to shade the union of A and B with orange here. And remember, the union is one or the other. This is an or statement. So I'm either in B, or I'm either in A, or I'm in both. So everything inside the circle. Well, notice, if I then take everything that's outside the circle, everything that's not within that union, or the complement of that union, now I have this shaded region, which is exactly the same region that I shaded blue in the previous diagram. So we can write another identity here, and that is that the intersection of the complement of A and the complement of B is equal to the complement of the union of A and B. And again, that's another identity that's always true for two sets. Okay, let's look at an example problem. So here we want to draw the intersection of the complement of A with B. So we need a Venn diagram, and I need two circles representing set A and set B. And when I say draw, I mean really we want to shade. Show on the diagram below by shading this intersection. So the first thing that we want to do is shade the complement of A. And it would be helpful if we knew which set was A and which set was B. Okay. So now we're going to shade the complement of A, which again is everything that's outside of A. Everything that's not in the circle, A. Okay? Then we want to shade B, simply the set B. Well, set B is everything in here. Now, intersection, remember that intersection means and. So I want to find all the elements that have both red and green shading. And we can see that it's this section of the Venn diagram right here. It's sort of this moon-shaped section, which is just the portion of B. So one way to write this in a sentence would be the elements that are in B but not in A.